And good morning, everyone. Welcome to our seminar, part of our GSUR Technology Training Program. I am so pleased to welcome Dr. Nikki Stricker to our program as our speaker today. I am looking forward to what she has to say. Dr. Stricker is an associate professor of psychology at Mayo Clinic, College of Medicine and Science. She is a very busy person. She is she's a board certified clinical neuropsychologist, director of the Adult Neuropsychology Fellowship Program at Mayo Clinic. And she has not only been maintaining a funded program of research within the field of Alzheimer's disease, but also maintains time in clinical practice and education. Her current research area focuses on an area that our program has been trying to understand for quite a few years now, specifically remote cognitive assessment in aging and Alzheimer's disease. And that's what she's going to be talking about today, bridging remote cognitive assessment research and clinical practice, looking at digital cognitive measures to keep up with changes in technology and facilitate translation of these tech advancements to clinical practice. For those in the audience, if you have questions, feel free to type them into chat or raise your hand if you would like to ask them during the presentation. Otherwise, we will make sure all these questions get asked at the end of the talk. So Nikki, I will turn it over to you.
Great, thanks for that introduction. And I'll just also highlight, do raise your hand, and Brian, I would look for you to monitor for raising of hands and interrupting me if there is a question that I otherwise might not notice. So thank you for doing that. All right, let me make sure my advancing is working. There we go. Just note some relevant funding sources. There's no personal compensation or any official conflicts of interest, but we are the developers of the platform and one of the tests that I'm going to talk about today. So I always think that's a relevant disclosure to report. All right, so today we're going to cover very briefly, what is remote cognitive assessment, and really focusing on aging and Alzheimer's disease options in this space. And then I'm going to tell you about the Mayo Test Drive Model and give you an overview of our research using Mayo Test Drive, covering, what is behind the development, what we're doing with validation, some data on usability and feasibility, and also clinical translation. You all know about neuropsych assessment, but I think it's helpful to kind of take a slide to outline the different ways that neuropsychologists do assessment that's been really changing since COVID started, and highlight when we use digital cognitive tests, when we don't, and what I'm going to be talking about and focusing on today. So obviously the top in green is our traditional in-clinic neuropsych assessments, where most of the time we're doing paper and pencil tests with interactive administration with a psychometrist or neuropsychologist. And sometimes we might include some digital cognitive assessment, whether that's self-administered, like if you do the Wisconsin card sorting test on the computer, or you use the MMPI-2 and it's computerized and makes use of the efficiency that goes along with a digital measure. Another option is to do remote assessment that sort of mimics an in-person cognitive assessment. And, we talk about telehealth, and this has got increased focus and use since the start of the pandemic as well. But here we're usually still using our traditional methods most of the time. We will, focus on using methods that just require verbal interactions, and those translate very well to telehealth models, or we might use screen sharing of stimuli, if we're using video to communicate and assess during telehealth. And some individuals might incorporate some digital assessments into that, whether they provide it to patients pre-visit and incorporate it, or another model. And then the last category is really self-administered digital assessment. So that's kind of a different class than the interactive assessments. And there's a lot of different terms that go along with this, so it's just helpful to outline them. So you can have these kind of assessments be supervised or unsupervised, and you can obviously do them in a clinic or remote. So what we'll be focusing on today is remote, unsupervised digital cognitive assessment. The need for remote cognitive assessment really got highlighted with the COVID-19 pandemic, but there's plenty of reasons that it's of great use even outside or after the pandemic. I think one of the prominent reasons we think about it is to increase access. This is often notable for us at Mayo. We have patients who come here from all over the country, so we can test them when they happen to be visiting, but we can't do any easy monitoring outside of when they physically travel back to Mayo Clinic. And even some, individuals have a hard time taking off a full day of work, for example, to come in for a really long neuropsych appointment. So increasing access is one of a key component. Increasing the efficiency of cognitive screening is another. It takes a lot of time for, like in a primary care setting, for example, for people to do a MOCA or an MMSE or something like that. And if you could do something pre-visit and have the results, that's time saving. I think there's some utility for triage. You want to see patients who are most in need of our assessments when we do a full eval. So that's another potential use. As I mentioned already, longitudinal monitoring could be facilitated for people who aren't nearby clinics. And then the Alzheimer's disease field kind of presents a unique element for this need. So with the recent clinical trials focused on anti-amyloid monoclonal antibodies, there's more need to enrich clinical trials for those most likely to have MCI or mild dementia due to Alzheimer's disease that's biomarker confirmed. And then once these treatments are disseminated, which is happening now, we need clinically to help determine more efficiently who's eligible for treatments. So this is another kind of use case. Given this need, there's really been an explosion of work both on the research side and the industry side, and there's a number of different options for remote cognitive assessment. It's almost overwhelming. You can't quite keep up with all the work that's happening in this area. And there's so many different ways that you can divide all of these things. What platform they are, are they PC only? Are they tablet? Are they any kind of iOS or Android device, be that smartphone or tablet, or only smartphone? There's a variety of options here. I think the difference between those that are single session focused and multi-session or burst focus is one useful way to divide these classes of assessment. And this is relevant for us, and I'll explain why. So Mayo Test Drive is not a burst model, but I wanted to talk about a burst model a little bit because it's very relevant to the remote assessment research literature that's out there. And here is one example of a typical burst design approach. So this is a figure from Jason Hassenstaub's group, a recent paper they have in GENS. That kind of lays it out. And the three little icons are the three different tests in the Ambulatory Research and Cognition app. And you can see that a typical schedule would be for a participant to do this 4 times a day across 7 days. And there's a general principle with psychometrics that the more there's, with normal tests, the more items you have, the longer the test, the greater the reliability. So the same principle is at play here. The more sessions you have, the greater the reliability. And that's one of the reasons for a burst design. I think the other really notable reason is that it allows for investigation of different questions than a single assessment design. So many assessments are often called ecological momentary assessment, and this allows researchers to look at the transient effect of changes in mood or time of day or hypoglycemic episodes, and so there's a lot of utility there. On a practical side, if we add up the time it takes to do all of these assessments, so let's say each subtest takes a minute, we have 3 subtests any session, and you get people to do 21 to the full 28 sessions that you're looking for, and you add that all up, that's 63 to 84 minutes. So even though these are super brief, that's still quite a lot of testing time combined together. Our focus with Mayo Test Drive is really on clinical translation. And so this is one of the reasons that from the start, at this point in time, we decided not to go with a burst assessment model because part of our clinical translation goals are to really start with clinical utility at the center of development principles and where our entire goal, and then work from there. So I want to explain for a minute that Mayo Test Drive is both a cognitive testing platform and a test development model. And the name stands for Test Development through Rapid Iteration, Validation, and Expansion. And we emphasize kind of different core principles. So clinical translation is really at the heart of what we're trying to do. We're using digital self-administered test, prioritizing remote assessment needs. We have a very small agile team. So obviously we are not the only two people working on this. We are fortunate to be embedded within a rich center. And I'm fortunate to have collaborators who are very supportive of integrating Mayo Test Drive into their research programs. But it's myself and my spouse who develop and kind of manage the nuts and bolts of Mayo Test Drive. My spouse, John Stricker's from the same joint doctoral program in clinical neuropsychology that I graduated from, but he went off and became a software engineer on top of that, and then has now circled back around to be in the Mayo Clinic Neurology AI program. So that's kind of another unique aspect of what we've done. We believe in having a very specific use case focus. So we're not just, oh, let's develop a whole battery of tests, not thinking about what their purpose is. So we have a whole battery. That's not the approach we're after. We're going after a software development model where you have a specific use case that you're programming for and a goal that you're trying to meet that provides rational, thinking and decision making for what you're trying to do. And that really drives the decisions. And then interdisciplinary collaborations are really key to this model as well. So here's kind of what it looks like when you think about a cycle of development and iteration. So at its core, as you can see here, is clinical utility, which really is impacting all stages, but we design what we're going to do, go through construct validation, normative data and clinical validation, and then hopefully get to the sharing and dissemination stage. And then as another use case comes in, we hope to restart the cycle and keep that model going. Another key element of the model is the need for iteration. And I really like this quote by Laura Jameen and colleagues: in digital neuropsychology, tests are software. So we have to think differently about how we think about our tests, how we plan for what's going to happen in the future. And I think there's two really good examples of what can happen in technology and how that might impact your research or your practice. And so the NIH Toolbox is one example. This is a super impressive endeavor that helps to harmonize cognitive assessment in a brief way across numerous different NIH-funded studies. But it also provides a example of how technology changes dictate what happens over time. So this was initially released as a web-based platform that was done on a PC, desktop or laptop, and released in 2012. And very soon after that release, they realized the need to transition to iPad. So in 2015, version 2 was released specifically for the iPad. And then just in March, I went to a webinar where I learned all about version 3 that's coming up, and learned that version 2 is going to completely expire. So you won't even have the ability to access version 2 in 2025. Version 3, they already have data showing some pretty good correlations with version 2, but it's kind of like a shift from the WAIS 3 to the WAIS 4, the WAIS 4 to the WAIS 5. It is different. It's not the same. It complicates longitudinal studies. And then the other example that I wanted to point out relates to our own experience with the Cogstate, which is one of the founders of computerized and remote cognitive assessment, and they've done a ton for the field. We've also done a lot of research in this area, and I'll tell a little more about that on the next slide, but basically the version of Cogstate that we were using for at-home use in the Mayo Clinic study of aging was dependent on Adobe Flash. And your group probably remembers not so long ago that that was no longer supported as of the end of 2020. And so we were faced with a decision in the Mayo Clinic study of aging. We had this home version that we were using. COVID just is happening. And now we can't use the version that we were using at home. We'd have to upgrade to version 8, which is actually a different version with a different number of items, different instructions, unclear equivalence because we haven't seen the data, and we would have had to build our own website to provide a front door to this. So there's already going to be a lot of work involved for us if we switched. So this is kind of the backstory behind the emergence of Mayo Test Drive. We had been thinking about doing this for quite some time, but this was the kind of, this plus COVID was the impetus needed to say, okay, time for us to do this. And so our use case was remote assessment needs in the Mayo Clinic study of aging, where early AD detection is our focus. And then as a clinician and practicing neuropsychologist, I have a real interest and emphasis on clinical translation, both with neuropsych tools, but also with normative data. That's like a whole other line of work that I do. And so that's another kind of key element. So just briefly, the Cogstate Brief Battery had been going for quite a while in the Mayo Clinic study of aging before I even got to Mayo Clinic in 2016. So they started it in 2012 in clinic only. And then and they brought people in for a midpoint. So there's 15-month visits recurrently for the Mayo Clinic study of aging, which is a population-based study in Olmsted County, Minnesota. You can see on the picture there. And people are randomly sampled from our county through the Rochester Epidemiological Project. And so it's a unique sample. And in 2015, we began to offer an in-home option for Cogstate for those who wanted to do it. In addition, kind of separately, there was a little bit of work done to ask participants in clinic if they preferred a home version or the PC version of Cogstate or a tablet version, and there was a strong preference for tablet, partially due to like arthritis and clicking issues with mouses for our older adult population. And then the whole thing that I just explained with the home version of Cogstate expiring. So I'm going to take a super brief aside to tell you some of the highlights of our Cogstate research that we've done. And for those of you who haven't heard of Cogstate, just tell you what it is. So there's a detection task, which is simple reaction time, identification, choice reaction time, one back working memory, and one card learning visual recognition memory. This Cogstate brief battery is what is in the Cognogram system, but that's marketed for class 2 medical device used by like primary care and things like that. And I had an Alzheimer's Association award that helped answer these questions here. So that included, can this brief battery help detect cognitively unimpaired individuals with positive AD biomarkers? And the answer was the area under the curve wasn't significantly better than chance. And it was a little worse than the auditory verbal learning test. So there's a little bit of signal, but the AVLT was doing better. And then the other question was, does change over time offer any benefit over a single assessment? And we found that the answer was no. And then relatedly, we looked at, can the Cogstate brief battery detect MCI at the level of the individual? And there's an area under the curve for this of 0.75, which isn't bad. But the issue comes up when you apply the normative data that they provide. And then when you do that and apply a -1 standard deviation cutoff, then the sensitivity is pretty low. It was 35% for amnestic MCI, 38% for all MCI participants. And then it did go up when we refined our sample to those MCI participants who had amyloid and tau positivity confirmed on PET scan to 73%. But that's a sample that has pretty prominent memory impairment. So I'd like to see it even a little bit higher for that sample. So, here we are, 2020, COVID's happening, and we can't use the home version of Cogstate anymore. So we thought about, okay, what is it that we need for remote cognitive assessment? And these are kind of the goals. We want sensitivity at the level of the individual, not just for group level analyses. Sensitivity specific to Alzheimer's disease, utility for longitudinal monitoring, has to be simple to use with relatively minimum burden. So less than 20 minutes is great. We wanted a single assessment approach, easy, like single click access to the test without having to download anything or remember a password or log in. A lot of participants with Cogstate said, hey, can't you send me something I can just do on my smartphone? So, and we knew that people preferred tablet. So we wanted something that covered all three device platforms. And then we were offering Cogstate predominantly in the clinic, but we wanted to, partly due to space concerns, to shift to a predominant at-home model for that. So that, this is the same thing I showed you earlier, but subtracting 3 years pretty much in terms of what was available at the time. So we kind of started out with, all right, well, obviously we have Cogstate and CanTab is out there. Branch and ARC were just starting to publish at or present data at conferences, but there were no publications. NIH Mobile Toolbox, we knew it was coming. And then there was these other options out there as well. But if we start to apply our requirements, then it cuts down a little bit. So if you have to be smartphone compatible, that knocks out a big portion of what you might consider. We're left with that. And then, as I mentioned before, we didn't want burst. So another part of the reason that we didn't want a burst model is we looked at some of our internal Cogstate data over the years to see how many people are doing Cogstate. And to explain this, Cogstate was a core part of the MCSA protocol. So when they signed the MCSA consent, this was embedded in there. We didn't need to ask them separately. And despite that, 17% of participants who were supposed to do it never did it at all, even in the clinic. People just would be like, I don't really want to do that. It's computerized, no thanks. And then of those who did it, 58% only ever did it in clinic, and 42% at least tried one at-home version. But if you looked at the MCI participants, only 17% of those individuals had at least one at-home visit. So we knew that there was going to be some challenge in switching to an all remote model. And we have a lot of people who are over 80, including some individuals who are over 100. So we didn't want burst. So that leaves us with only a few options. As I mentioned, Branch had some promising data presented at conferences, but nothing published. The Mobile Toolbox had a projected release of around now. And then BrainCheck and SabNX really didn't have any scientific validation. Test My Brain is a really, really cool platform for citizen science, but they don't have a focus on older adults. And a lot of the research doesn't include, the older research anyway, didn't include individuals over 70. So that led us to develop Mayo Test Drive. This is kind of a single screen snapshot, and then I'll go into a lot of details. But as I mentioned, this is a multi-device platform, so compatible with smartphones, tablets, and personal computers. In our first published pilot study, we reported 98% completion rates, suggesting it's easy to use. And we designed it specifically for remote assessment needs. Takes about 15 to 20 minutes, includes a measure of verbal memory and a measure of processing speed. We have evidence of convergent validity, adequate to good reliability, and minimal practice effects, and good diagnostic accuracy in early data with amnestic MCI. So I'm going to talk through some of the development and test selection decisions and different things that we considered as we started this process. We knew we needed a memory measure, but we identified that we needed to develop something new to meet the goals that we had. We wanted to avoid voice data as well, because that complicates privacy issues in interacting with the test. I'll spend the first few slides talking about the processing speed measure we selected, and then I'll circle back and talk a lot about the memory test. So Jason Hassenstab developed the ARC Ambulatory Cognition and Research app. And one of those measures is the symbols test. So I think this slide is nice for a couple of reasons. It helps justify why we chose the symbols test, and helps me point out a couple points about the burst design model and how that impacts reliability. So this figure here is the same data as the numbers, and depending on if you're a figures or number person, you can look at either. I usually go towards tables, but you can see that after 3 sessions, the symbols test achieved a reliability of 0.88. Other measures that are in the battery took longer to reach, a 0.8 or a 0.7 level. With prices is an associate memory measure, and that didn't really reach 0.74 reliability until 14 sessions. So yeah, they have these 3 measures in their battery, repeated over and over. The symbols test, when I talked to Dr. Hassenstab, he's like, everybody thinks this is a fun test. People really like it. I'm like, great, can we pull it in? He's super easy to work with and a great person. So I'd encourage working with him whenever possible. And he's made these measures open source, so we were able to pull that in directly to our platform. We basically have an adapted version of the symbols test. It's run exactly the same, except we do 4 sessions in a row. So there's 12 item sessions, and we repeat it 4 times within our single session approach. And in our pilot study, we showed ICC of 0.83 with this kind of 4 session mini burst. We also have data showing that this measures processing speed and executive functioning. And then the primary outcome variable here is the average correct item response time across the 4 12-item trials. I've also made an accuracy weighted version of this because I found that people who are fast and make a lot of errors are fast on all the items. So, and it means something when you make errors because it's very uncommon. Most people are at ceiling for the accuracy rates, and I've observed that people who are impaired on the memory test are pretty impaired on the memory test also make errors on this, suggesting there's like a working memory component that's at play as well. All right, so now I'm going to change gears and talk about the rationale and test design decisions for the Stricker learning span test, which is the memory measure that we include. And this kind of goes back to a question I've been developing for a while, which is, have we been overemphasizing delayed recall and forgetting in Alzheimer's disease? And if you look closely in the literature, you start to see that there's some evidence that what we think of as forgetting as neuropsychologists might be a side effect of test design. We do see high recency effects in Alzheimer's dementia, but the question I have is, at least some of those items might not have ever been encoded in the first place. So if you think of classic recency effects, you have a list of 15 words. Someone with an Alzheimer's dementia profile might be repeating back 1 or 2 from the start of the list and then 3 to 4 from the end of the list, but they never really learned those words because they were just in working memory. So just spit them out. And then when it comes to delay, of course, they're not remembered. And then we think that that's forgotten, but really they just didn't learn it. Some early learning to criteria studies that equated initial learning also provide evidence for this, suggesting that the deficit might really reflect impaired learning rather than accelerated forgetting. And more recent work has corroborated this and is suggesting that learning is really a key deficit across the AD spectrum and might be a central deficit in the preclinical and prodromal phase. So if you shift the focus away from delayed recall and you suddenly don't have to give everyone the exact same exposures to the stimuli, then you can really design a memory test in a very different way. And we took a computer adaptive approach. So the SLS starts at 8 words for everyone, and then it goes up or down depending on performance. And these lines just indicate the possible kind of ceiling of items presented and the floor of items presented. Then the next slide's a little overwhelming, so I apologize for that. But it lays out the specifics of the test design. So we generate 23 item bins, and every bin is kind of a similar set of words. And then every session randomly selects one target item from each bin for that session because there's randomized alternate forms. When you present the list of words, the word list order is randomized, except the last item presented is never the first tested. And then, so they see each word one at a time for the, exposure, and then each each kind of recognition testing trial is a 4-choice recognition response selection. And then you can see here how our decision rules are laid out. So if they get more than 60% correct, then the list increases by 5. If they get more than 30% correct, but less than 60%, then it stays the same size. And if they get less than 30% correct, it decreases by 2 words. This briefly kind of summarizes some of the cognitive science that contributed to decisions made regarding this test. So the first isn't cognoscience, it's practical need. If you're doing a remote assessment, it's easier and more feasible to have a recognition-based test. And if you look at some of the literature, there's earlier evidence to show that if you use a 4-choice format, you can see similar sensitivity as recall-based formats. We use common high-frequency words that are easier to recall but harder to recognize. And we took the 250 highest frequency words, merged those with word imagery data to generate our 23 item bends. And the initial 3 items are the easiest, and then the items get harder and harder to help extend the floor and the ceiling. I'll point you to this paper for the details, but we did publish a paper last year in neuropsychology where we did some neural network models to make some points about how we think this works. And we show that if you have a context input in the model, this helps you to avoid catastrophic interference that can occur with these kind of networks. And so this leads to the hypothesis that context is required to organize information as it's learned, or it's going to be forgotten because of interference, and helps support the idea that forgetting, again, might be a side effect of how you test information and just a side effect of interference. So forgetting is an inability to separate episodes of learning, and we can learn in the moment, but we rapidly forget if we have a problem with this context when new learning overwrites that. Try to summarize that one more time here. So it's our development summary for the decisions around the memory test development. So we emphasize learning and tax the ability to use context to separate or tag unique episodes of learning. If you've ever heard of the hippocampus as like having a tagging mechanism, it kind of applies. We think this system is vulnerable in early AD. Because of this, we want to use stimuli that are relatively context-free or overlearned, like high-frequency words. It makes them harder to say, when did I see this? Was it part of this list or just reading the newspaper this morning? So it's emphasizing memory for a specific episode of learning. We also considered past literature demonstrating that wordless memory tests are really one of the most sensitive ways to get a signal in early AD. And then our test and outcome variable format is tailored for remote digital self-administration. Other platform considerations are ease of use, I've already mentioned, web-based compatibility for multiple device compatibility, consideration of use of different devices when selecting the outcome measures for each test. So I did an entire paper on the Cogstate measures comparing performance on personal computers and tablets, and looking through exactly where those differences are. And it's mostly the speed and task, especially when you focus on simple reaction time, that those become problematic. So we wanted to pick outcome measures for tests that minimize any simple reaction time. And instead, it's okay to get like total thinking time, but at some point we just have to accept that there'll be a little bit of device differences and try to minimize them as much as we can. Our platform also includes questions about test interference after each subtest and allows participants to put in comments at the end. There was an eye tracking study published a couple of years ago that showed that about 7% of a large number of remote sessions had one or more distractions. So it's important to have some way to capture that data. It's not going to be perfect because you're not observing them, but if we try to provide some of those opportunities, people do give information that's helpful. And then the last design decision was to avoid PHI or PII in the Mayo Test Drive system to reduce privacy concerns and really facilitate sharing. All right, I'm about to switch directions and talk about validation next. So definitely let me know if there's any questions so far. I'll keep going until I hear there is any. So we have done work in pretty much 2 different data sets. Our early pilot study, was done in the Specialized Center of Research Excellence on Sex Difference or SCORE study that Michelle Mielke is the PI of. And this was individuals who were female, 55 and older, with and without bilateral hysterectomy. And that data collection started December 2020 and recently got completed. And then our other main emphasis is in the Mayo Clinic study of aging, with a small number of people also recruited from the Mayo Alzheimer's Disease Research Study. And this is the population-based sample that I mentioned. People are 30 years or older. Nearly all the sessions and data I'll be presenting today are remote. We've had like 15 individuals do it in clinic out of over 1,200. And we had an initial pilot phase from May to October 2021, where we targeted first people who were in our prior home-based study, just to make sure they could do it. Second, people who were 80 and older who were specifically not in that study to make sure that they could do it, and then people with MCI. And then after we got through that phase and everything was going pretty smoothly, then we invite everyone coming in for an MCSA visit to do this study. But it is set up differently than Cogstate in that it's voluntary. It's an ancillary, uncompensated study that we give people a handout when they come into the MCSA visit, so they have a sense that they might be getting an email from us. And then the consent elements are in the email, and they can, it's a oral consent, email consent. So if they click on the link, that is considered consent for the IRB. Going back to the SCORE study for a moment, part of the Mayo Test Drive model, if you will, emphasizes that we really need to have a way to rapidly pilot initial research and have a place to do some early iteration, because you always are going to discover things when you start rolling out a new technology. We're doing QA testing ourselves, but user feedback comments are also very helpful. So I just wanted to outline, first how quickly we did this initially, partially because of COVID and all of that strangeness, but we decided we were going to do it in February, and then we had initial beta in May of that year, 2020, and then started data collection in December. So it was pretty fast. And then I provide, given the nature of this group, just some examples of some of the iterative development steps that we took. There was one substantive iterative development very quickly early on. Initially, we only had 5 trials of the SLS, and we didn't include the delay after symbols, but we decided to add it. So we added that. And then all the other ones are just kind of minor technological improvements and updates. So we disabled the back button. And if somebody tried to close their website, there's a warning to try to prevent them from doing that. We added a response input selection. So like asking people, are you using a mouse? Are you using touch, etc.? Because although you kind of can assume that based on their device, it's more and more hard to guarantee. People use trackpads. I think nowadays tablets can use mouses, so it's kind of a hard variable to be sure about. We changed, one of the users gave us feedback. I just couldn't bring myself to not put in a comment and hit submit because I was worried that my data weren't going to be saved. So we changed our wording on that screen to make sure people were confident that their data were saved and uploaded. When Internet Explorer stopped being supported, we stopped supporting it as well. And then there was a new pull to refresh problem that came out with some update on Safari on the iPhones that we had to fix last year. All right, given the time, there's a lot of information on these slides, but I'll just try to hit some key points. So this just shows evidence of good test-retest reliability over about 13 days in our initial pilot study with ICCs that are moderate to good for the memory measure and the symbols test. Here we see that our randomized word lists are helping to mitigate the practice effect problem for the SLS. So there's no significant practice effects for the memory measure, and there are only mild practice effects for the symbols test. And here we have initial early evidence of criterion validity. A subset of the women that we had included in this study had neurodegenerative markers. And we showed that with partial correlations that corrected for age, sex, and education, a number of the SLS variables showed significant associations with intrarenal cortical thickness and what used to be called an 80 signature cortical thickness. They changed the name because it's really nonspecific to temporal meta ROI, but those were showing correlations. Interestingly, in this subset, the AVLT correlations weren't reaching significance, but some of them were just under threshold. And then hippocampal volume in this sample didn't reach significance. This is a sample that's mostly cognitively unimpaired, and a lot of studies that look at associations are in people with MCI and dementia, which is probably one of the reasons behind this finding. And we didn't see any significant associations between symbols or traditional processing speed measures and these in markers. I include this because these are two participants from this cohort, but I think it's a nice illustration that the learning curves that we see for the AVLT and the SLS look kind of similar, which is great given that one is recall based and one's recognition based. So on the left, we have the AVLT, and on the right, we have the SLS. And in the dashed line is a high performer who, shows high average overall learning on the AVLT, and they similarly have a very strong positive learning slope on the SLS. And then the dark line is a low performer who has mildly to moderately impaired total learning on the AVLT, and similarly kind of a more flat learning curve on the SLS. Turning to some of the validation data in the Mayo Clinic study of aging, here we're starting to introduce a Mayo Test Drive composite variable, and we've done that two different ways, one with like a typical averaging of z-scores, and then a second one that is a raw composite, so adding the sum of trials and the accuracy weighted symbols response time. And the hope is that this could allow Mayo Test Drive to function like an MMSE or a MoCA, because my other line of research shows that particularly in individuals over 80, norms become pretty problematic in terms of kind of messing up early detection of MCI and early dementia in people who are over 80. And so that's the rationale between looking at that alternatively. In 2022, at AAIC, we presented this initial diagnostic accuracy data for amnestic MCI with the composite measure and the SLS measure showing area under the curve over 0.9 or above. The symbols measure has 0.77 area under the curve, but that's to be kind of expected given that it's a processing speed measure. We have some evidence of convergent validity with AVLT and SLS sum of trials showing 0.63 correlation, coding and symbols showing a 0.64 correlation, and then the composite and our Mayo pack, which is a recently published pack that we have, show a 0.67 correlation. Other encouraging data, it was exploratory, but I was happy to see the correlation of 0.59 with symbols and Trails B, because in any remote assessment environment, it's really hard to get a measure that's like Trails B, and so that was pretty encouraging. Now I'm going to take you through a couple slides highlighting data that we had a paper just accepted a day or two ago in GENS that's available now as a preprint. And we presented this subset of the data at INS in February. Here I'll focus on the cognitively unimpaired sample, but the paper also presents, we have a handful of individuals with MCI and maybe one or two with dementia in that paper as well. But our hypothesis here was to show that the SLS would differentiate biomarker-defined groups as well as the AVLT. And then our second hypothesis was that for both word list memory tests, that learning trials would differentiate these groups as well as delayed trials. This is predominantly Mayo Clinic study of aging participants. We defined if they were on the Alzheimer's continuum by amyloid positivity or negativity. And then we defined if there was evidence for biological Alzheimer's disease based on amyloid and tau PET positivity with imaging or not, then they were negative. And again, all these participants were cognitively unimpaired. These were all remote sessions. So we'll look at this data in two ways. First, on the left is those who are just A+ versus A-, which we expect much smaller effect sizes consistent with the literature. But the focus of this analysis is just showing that the effect sizes for the AVLT and the SLS are very similar. And then we see larger effect sizes in groups defined by biological diagnosis of Alzheimer's disease. And again, you see pretty similar effect sizes across the AVLT and the SLS. And when you adjust for age, sex, and education, the effect sizes decrease to some degree. The next slide is busy, so I'll just talk you through the main points, but we want to do a formal test of whether the SLS and the AVLT were separating groups differently or not. So we did area under the curve analyses and did a statistical test comparing the area under the curve and none of the results were significant. So that suggests that the SLS was doing as good of a job as the AVLT for different differentiating groups. Our area under the curve values differed depending on whether we had only the test score in the model or if we also included age, sex, and education. And it was more, moderate. They were significantly better than chance for all the models. So, you know, uh, significant effects, but more in the 0.63 to 0.69 range. But if you add age, sex, and education into the model, for example, for the SLS sum of trials with age, sex, and education, the area under the curve is 0.83. And then this slide is just to highlight the hypothesis that learning measures did show similar ability to differentiate biomarker-defined groups as delayed recall measures. They're pretty much perfectly aligned, suggesting equal utility of the learning measures. So to summarize that data that we just talked about, the SLS has good criterion validity compared to a gold standard in-person memory test. There's evidence that the SLS is sensitive to preclinical ID, and our data suggests that learning trials are equally as sensitive as delay trials. This we presented, it's the same cohort of data, and we presented this also at INS. This shows data supporting the Mayo Test Drive composite. So we're combining the SLS and the symbols test. And what we see here are, we're only looking at biomarker, those with a biological diagnosis of Alzheimer's disease, so that A plus T plus group compared to those without, who are cognitively unimpaired. And this is our composite, the remote MTD composite. And then the orange is a global Z-score. So this is the average of 9 neuropsychological tests given in person. And then this pink, which is not significantly different across the groups, is the short test of mental status, which is like an MMSE. So this data shows that this composite is performing about as well as 9 in-person measures and better than the STMS MMSE-like measure. And here just shows the breakdown within the sample of device use. So we were actually somewhat surprised by this. The majority of our participants, 62%, used a PC, 27% used a smartphone, and 11% used a tablet. Even though it is predominantly PC heavy, I think making sure you have smartphone compatibility really is critical, because there's data to show that Hispanics and Blacks own smartphones at a similar rate to whites, and more individuals, particularly those who are lower education and lower income, only have smartphone access to the internet. So we don't want to exclude that population. And as more smartphone users age, I think we'll get better representation in older samples as well. Okay, I'm mindful of the time, so I'm going to go through this last little bit kind of quickly, but it's fun data, so I'll just highlight it. So the next couple slides talk about usability and feasibility of the platform and user design factor elements. And so we're incorporating element definitions adapted from Armipur et al. So usability is the extent to which a measure can be used by the target population. So can people use it and complete a task? Is it easy to use and not frustrating? Acceptability is factors that influence willingness to assess cognition through digital assessments, and that can be represented as openness to technology and what your participation rates look like. And then face validity is obvious. So our primary hypothesis with regards to usability was that we'd see completion rates greater than 90%, defined as those who complete a session divided by the number who initiate a session for any planned time point. I briefly mentioned earlier that in our initial pilot study, we had 98% completion rates and a median completion time of 15 minutes. So now I'll show data in about 250 participants in the MCSA and ADRC. And then we'll look at some comment data from a much larger sample that we're replicating the other analyses on. But we looked at the comments people left and rated those in a variety of ways. So first is willingness to participate data. So we can see a definite effect of individuals who are cognitively unimpaired versus not. So people who are cognitively impaired are less willing or interested in participating in a remote cognitive assessment ancillary study. So we had about 52% participation rates there. whereas in the cognitively unimpaired group, we had 77%. But the good news is if they were willing to try it, then everybody had a good chance of completing it, and there wasn't a significant difference across these groups. So we still showed 98% completion rates overall, with 99% in the cognitively unimpaired group and 96% in the cognitively impaired group. And then here's just a snapshot of how different comments at the bottom are specific participant comments fall into these different categories that I mentioned: face validity, usability, acceptability. We also have a behavioral observations proxy category because as neuropsychologists, we want to know what's going on in the session. And a number of people gave us that information. So like somebody said, a weather alert went off in the middle of the test and was a distraction, or I sneezed on one of the timed measures. And then one of my favorite kind of funny ones was, I can remember things about the Green Bay Packers better. Maybe use those words next time. So that was, constructive feedback sort of, and endorsement of the test as assessing memory. So these are kind of fun. And this is very preliminary because we have some refining of this to do, and we may change how we classify things. But 36% of individual or of people with any session left a comment. So 36% of all sessions had a comment. And then of those, 9% related to face validity, 14% usability, 76% acceptability, and then 22% the behavioral observations as a proxy, which again is very clinically useful. So those are my favorite because they help me understand what happened in the session. So to summarize those results, we showed good usability rates. There was relatively low technical problems spontaneously reported at 1%. Acceptability, cognitively impaired individuals have lower acceptance of digital measures, and that might influence participation rates. But looking at comments, we had more positive comments, 21%, than negative comments, 1%. So that was somewhat reassuring. And then we had some evidence of face validity in our spontaneous comments. Clinical translation is kind of the core of Mayo Test Drive. So although I only have one slide about this, it's informed every decision along the way, not burst, how we design the test to have a low floor. Instead of saying, let's build something for research and then plopping it over to clinic, it's let's build something that works for patients and it should also work in the research setting. So it's really a key element of how we think. It's probably a factor of me being a clinical neuropsychologist. We also have an iterative norm approach. So we had first norms available with our first pilot study for older women. And then as the MCSA sample has increased, we've gotten more and more iterative norms, and we're over 1,100 cognitively unimpaired individuals now, and are going to start working on a more formal normative paper for that. In line with my goal to translate, I began using Mayo Test Drive just pretty much myself and with some of my fellows in our clinics about a year ago. We haven't got all the automation pieces set up, otherwise it'd be really easy for other people to use. But because we don't have PHI in the system, I'm careful about maintaining that use until we have that all working smoothly. And then we have a plan to include this in an upcoming 80 Therapeutics clinic in behavioral neurology, which is really facilitated by an institutional emphasis on trying to innovate and incorporate digital measures. And then we're in the early stages of a collaboration with the National Neuropsychology Network and have a little bit of data with one of their sites at UCLA in a research format. Some of our future directions include a Spanish adaptation. If an R01 is funded, we'll examine diagnostic accuracy of MCI in much greater detail, look at longitudinal sensitivity, association with plasma biomarkers, and significantly expand recruitment of Black participants. We'll develop a portal in the near future to facilitate sharing of the platform for research and clinical use. Potentially long-term, this could be used for cognitive screening by non-specialists in primary care or geriatrics clinics. And then our goal is to develop the next measure or two and go through the cycle again, again, focusing on what do we need to develop to meet a specific use case and develop accordingly. So that wraps it up. We have at least a couple questions minutes for questions, but thanks again for your time and attention.
Yeah, thank you, Nikki, for your time, and really appreciate that talk. It was actually really insightful. We had a few discussion questions that Diane and I were talking about, but I was wondering if anybody else, Diane, if you want to ask one of your questions before you have to head out, or Maureen had a question.
Do you want to go first, Diane? I have a question.
No, go ahead.
Okay. Nikki, first, I think that the work you did on the Stricker learning span is really exciting, because I know trying to think about how do we create a memory measure that doesn't have free recall, but yet can act like a free recall measure, because we know that they're so sensitive. So kudos to you guys for coming up with that and like really thinking carefully about everything that, just even the word frequency and all of that. So that was really exciting. The question I had related to context, and you said like you got all these interesting kind of like behavioral observation information from people. Are you like including any questions about context, about like things that are happening, like where they're taking it, like how distractible they are, or are you thinking about doing that in kind of future iterations?
We have a location selection. So are you at home? Are you at work? Are you in a clinic? Or are you in a public space? So we have that. We don't have more. We also, after every subtest, we include, did anything interfere with your performance on this test? Yes or no? And then if they endorse yes, there's a selection of options or other, and we tell them there'll be a comments spot at the end. So that's one way we address that a little bit. But our goal is to really keep it streamlined, because people have to do it more than once too, often. And so we were going for minimal burden and sacrifice some other things. So we don't have other context questions beyond those.
Okay. Yeah, I was curious about like fatigue or mood, or yeah, if you had any correlations there. Okay, great. Thank you.
Sure.
Does anybody else have any other questions? I have a few from Diane that I will forward, but if anybody else has some, feel free to. Larry, looks like you
I have one. Can't seem to raise my hand, but hi, I'm Larry Holder. Great talk. I had a question early on. You were doing the prediction of AD biomarkers, and you made the comment that long-term collection of data didn't seem to help. And I guess my general question is, do you think that it might help in other things? I mean, I would think eventually some more longitudinal data collection might at least be able to predict trends or rate at which a person would get to that point. So
yeah, there's a great question. There's a couple things that go into that. One is we had relatively low reliability coefficients for the Cogstate brief battery data. And so that's what we were using to look at, was longitudinal more helpful than a single baseline assessment? And specifically it was, we took a point in time and then we compared the slope from a prior time point to that point in time cross-sectionally. And that's where we saw, well, that updated cross-sectional point did just as well as that much harder to get slope. And that's where that statement came from. The hope, of course, is that longitudinal monitoring would be helpful. And that's why so many people are trying to do it better, like with the burst assessment model. But at the same time, part of the rationale for the SLS was that wordless memory tests do so well. And Caselli and colleagues published a really nice paper and showed that that inflection point for the AVLT, for example, happens 20 years prior to the MCI diagnosis. So I think that it's really hard to capture that change because it isn't happening rapidly, and we don't have 5 to 10 years of data to make it more obvious. As clinicians, we do sometimes see that change, but not always. Like, saw someone this morning who I think transitioned from MCI to dementia, but they're tiny changes on neuropsych. It's pretty stable and only here and there. So it's really a challenge to detect longitudinal change. It's a good goal, and we'll still keep trying to do it for sure. But I think taking a data-driven approach to compare, well, is my longitudinal data helping more than my cross-sectional data with a variety of different measures is still worthwhile.
All right, thank you.
Last one of the questions, Dan and I were talking about, we were wondering, you mentioned the participant that mentioned the Green Bay Packers and the how that was something that they would be able to, maybe have more recall over. And do you think there's a a possibility or a use case for being able to tailor these kind of tests to a person specific, knowledge areas and recall? Because I know, obviously it'd be a lot harder to compare that across different people and to, do that kind of comparison. But, do you have any thoughts, or has there been any work you've seen about doing that kind of thing where you tailor it to a specific person to better get a handle on it, if you will?
Two comments related to that. One is Yin Lim and Paul Moreff did a really cool paper for that international shopping list test, showing that it's different but it's similar. You have cross-culturally, you need to pick the shopping items that people have in their culture. It seems obvious, but it's like, don't translate it, adapt it. So that's kind of one response, sort of related. It's like, well, what is of interest and relevance to me and my background? And then the other is more like for like intraoperative mapping, you might want to have that kind of personalized baseline so that if when I stimulate or make this area not work and they didn't remember those items, I know they remembered them fine last time. But it'd be pretty hard on a large scale, like to get sensitivity, because it would just be so hard to control. And they would do a lot better with the things that were familiar with them, to them. That'd be more if you wanted to have an easier test, I guess.
Right. Yeah. Like you could maybe, like kind of the international shopping test, you could tailor it to a large group of people based on their cultural preferences or whatever. But if it's, individual, it's a lot harder to do that. That makes sense. Does anybody else have any other questions for Dr. Stricker? I was also going to comment that, I'm a software engineer in Diane's lab, software researcher, and so we do a lot of Apple Watch prompting and things like that, where we do EMA questions on the watch. And so all of your comments about, having to adapt for different devices and having to, figure out how to, distractions, all those things, we've been through a lot of those too. And so I appreciated your viewpoints on that and some of the experiences you shared with having to learn how those things affect the older adults. And it was really interesting to me, especially that you were able to get that feedback from them on different devices they were using and how that all interacted together. So thank you for sharing that.
Thanks.
We should probably be mindful of everyone's time.
Yep.
So just want to thank you, Nikki, for that great talk. And I'm glad I have better understanding of your work. And I just love the approach that you've been taking and really checking all the aspects of your test and how well it's doing, and that access to the biomarker data and everything. That's so cool to be able to do all that. So thank you for coming.
Thanks so much for having me.
Presenting to our group.
Thank you. All right. Have a good
Have
day.
a good day, everybody. Bye-bye.
Take care. Bye.